This is Algebra 2 semester review. I'm just going to hit some of the main points here so you can fill in the other parts. We have, first of all, here, evaluate function should be pretty straightforward. This is read P of 3, and so to do this problem, you would put in a 3 everywhere that there is a T. And so generally when I'm setting these substitution ones up, I write the function with parentheses and then go back and plug in the number or the variable. So for this, I would set it up like this first and then evaluate. Remember, this is not x squared plus 1. You have to multiply x plus 1 times x plus 1. That should get you through all those. Find the inverse of each function. That's really goes with these two problems. To find the inverse, you switch. Remember, this f of x is just like y. You switch x and y and then solve for y. So for this problem, I'm going to multiply both sides by 8 to get rid of the fraction and then go from there. I am going to work out number 7. This one is one that was most missed on all the tests. So I'm going to put in x equals negative 1 over y plus 2 minus 2. This one's a little different technique. Move the 2 over. And so the problem is when we go to multiply this out, to get rid of the fraction, to get the y out of the denominator, it's going to be a little bit messy. So I have x plus 2 times y plus 2 equals negative 1. So I'm going to just multiply xy plus 2x plus 2y plus 4. Now to finish this problem, I need to get the y by itself. So I have two terms with y in them. So I'm going to factor out the y out of those terms. But before I do that, I want to move the 2x and the 4 back to the other side. So if you subtract 4 over here, this becomes negative 5 minus 2x, and I have xy plus 2y. Factor out y, greatest common factor, and then divide by x plus 2. And the order, usually the x comes first. It really doesn't matter here. So if you start out with a variable in the denominator, you're going to end up with some kind of fractional. It's not a linear function. Over here it says state if the given functions are inverses. There's a couple ways to do this. One way would be to graph and see if they reflect. It's not always reliable because you can't tell by just looking at it. The other way, if they're inverses, h of f should equal x, and it should equal f of h. Both of them, when you substitute one in for the other. So in case you forgot, to find h of f, that means that's the same as h of f. Means I'm plugging in the entire f for my variable. So 3/5 minus 6/5. I'm plugging in the 2 plus 5/3 n. It's just algebra simplification. If you get x, then you do the other way around. You plug h in for f. If you get x, then they are inverses. Perform the indicated operation. F of g of n is also the same as f of g of n. So just like if this was a 7, you'd plug in 7 in there. You're going to plug all of g of n in for n. So set it up first. I'm telling you, that little step's going to save you some issues. This is the same problem over here. When we get down to g of f of negative 5, again, remember, this is g of f of negative 5. So if you want to save yourself some pain, find f of negative 5 first, which plug it in right here, and then plug that in for the n value. So these two are numeric. The key is find this piece first. Okay, sketch the graph of each function. They're parabolas. The best thing to do here is to, if it's not in vertex form, is to find the vertex. The vertex is the opposite of b over 2a. That's the line of symmetry. That's the x-coordinate of the vertex. So for this one, it'd be the opposite of 8 all over -4. So the x-coordinate of the vertex is 2. And then you go back and plug in 2 to find the y-coordinate. So this is -8 plus 16 minus 6. So that's also 2. So my vertex is at 2, 2. And then we have a 1, 3, 5 rule for the value, the coefficient in front of the x. So if the coefficient in front of the x is a 1, we go over 1, up 1, over 1, up 3, over 1, up 5. But it's a 2, or -2. So instead of 1, 3, 5, we multiply by -2. We have -2, -6, -10. So I start here, and I go over 1. Instead of going up, I'm going down 2. And that means I have the same point. This line of symmetry is right down the middle. Then I go over 1 and down 6. 1, 2, 3, 4, 5, 6. And I just mirror that. You don't have to count. If you mirror it, you can see, and you kind of sketch it in there. We're off our graph. If you aren't sure if these points are on your function, you could plug them in here and check it out. I'm going to plug this one in. If x is 0, y is -6. It's always good to check the y-intercept. That should line up. So same problem here. Find the vertex, sketch it. This would be a 1, 3, 5. Find all zeros. Zeros are solutions. So if this was equal to 0, we need to find numbers that make the function equal to 0. They're also called x-intercepts. If you had your calculator, you could double check your answer, see if it made sense to see where it crosses the x-axis. So I'm looking here. I can't factor a cubic without taking out a greatest common factor. And then at this point, you factor using whatever method, if you're Xbox, if you're guess and check. And if you can't get a combination, then you use quadratic formula. And 5 and 2 would be my factors of 10. They don't give me a difference of -2. This is going to be a quad formula. So my solutions, I don't know what this function looks like, but I know it crosses at 0, and it's going to probably cross at a positive and negative radical. Again, if you graph, you can check your answer. I know there's my 0. I can calculate a 0 here. It's asking for a left bound. I go on the left side, right side, and then I make a guess. I hit enter each time. So that -2.31 something means that this was you had to use a quadratic formula to finish that. Identify domain and range. Remember, square roots have to be 0 or bigger. So my suggestion on this would be just to sketch a graph, and then you can see the domain and range. So the square root graph, basic square root looks like this. So I'm going to shift to the left 3, because if I plug in -3, that makes that 0, and I'm shifting down 4. So it's going to be some kind of a sketch like this. I'm not even putting all the numbers, but I know that the domain, the smallest value is -3. So it's